Written by Neil deGrasse Tyson, Hayden Planetarium, StarTalk. Section 1. Overture in the Void, a nebula's grand design. Imagine a time before time, a place before this place. Some 4.6 billion years ago, there was no Earth, no sun, not even a solar system, only a vast cold cloud of gas and dust, what we call a solar nebula. A cosmic nursery, ingredients for stars, for planets, debris from ancient suns. For eons it floated in delicate balance, hydrogen, helium, and a dusting of heavy elements. But the universe is never still. A nearby supernova's shock disturbed the calm. Gravity, the master architect, began collapse. As material fell inward, it spun faster, like a figure skater pulling in their arms. At the heart, a dense, hot ball, our protostar, ignited nuclear fusion. The sun was born. Leftover gas and dust flattened into a vast rotating potter's wheel, the protoplanetary disk. Within it, Earth's story began. Patient, violent accretion from motes of dust and ice, tiny grains to pebbles, rocks, boulders, runaway growth into planetesimals in a cosmic demolition derby. One planetesimal began to dominate its lane, the seed of Earth. Its gravity swept in dust, rock, ice, each impact bringing mass and heat. Impact energy plus radioactive decay turned the world red hot, then searing white, an incandescent globe. In that crucible, materials sorted by density, planetary differentiation. Iron and nickel sank to forge a dense core, the dynamo of our magnetic shield. Lighter silicates floated up, forming viscous mantle and a brittle crust. The surface? A global ocean of magma. No continents, no water, no air, just fire and stone. Volcanic outgassing birthed a primitive atmosphere, steam and noxious gases. The Hadean, named for the underworld. Core, mantle, crust, foundations for plate tectonics, the engine that will sculpt continents and oceans. And then came a transformative collision, on a truly planetary scale. Section 3. Theia's Kiss, a collision that birthed a constant companion. About 4.5 billion years ago, Earth shared its orbit with another world, Theia. Roughly Mars-sized, it closed in over millions of years. The final act, a glancing cataclysmic blow, vaporizing rock and hurling debris to space. Earth's surface re-liquefied, a world of molten seas. Theia's heavy core plunged inward, growing Earth's core. A ring of Earth and Theia debris encircled the planet, held by gravity. In mere thousands of years it coalesced into one great companion, the Moon. The impact tilted Earth, set our seasons, raised tides in molten rock, and slowed our spin toward 24 hours. Our Moon is a stabilizing partner, our cosmic anchor, and a reminder of Earth's spectacular birth. This is the giant impact hypothesis, explaining the Moon's size and mantle-like composition. Section 4. The Great Bombardment, a sky full of fire. From about 4.1 to 3.8 billion years ago, the inner planets endured relentless impacts. Giant planets shifted, flinging planetesimals, asteroids, and comets inward. Craters the size of continents, crust shattered and remelted again and again. A pockmarked world of lava flows and boiling basins. Stability denied. Earth's scars were erased by time, but the Moon remembers. Destruction, yet delivery. Water, ice, and organics rained upon Earth. As the storm waned, debris was swept up or ejected. Peace crept in. Crust cooled, protocontinents formed, volcanoes still vented a restless interior. A world of fire and rock was ready to become a world of water and air. Section 5. The world weeps, the genesis of oceans and air. As temperatures fell, a planet-wide torrent began, lasting millennia. Rain pooled in vast basins and chasms. Rivers carved the new crust. Shallow seas grew and merged. By the 3.8 billion years ago, a global ocean formed. A pale blue dot. Early light gases were blown away. A secondary atmosphere rose from volcanoes, thick with CO2, water vapor, nitrogen, methane, ammonia. Crucially, almost no oxygen. Greenhouse gases kept oceans liquid beneath a fainter sun. Oceans absorbed CO2. Rock reactions and the deep carbon cycle began regulating climate. Vast mineral-rich oceans, organics from comets. Earth became a planetary laboratory. Cool water, protective air, endless chemistry. Conditions were ripe for life. Section 6. A chemical whisper, the dawn of life. In shallow seas, organic compounds, minerals and water were energized by lightning, vents and UV light. Around 3.8 billion years ago, chemistry crossed a threshold. Self-assembling structures emerged, perhaps RNA within simple lipid membranes, protocells that harnessed energy and copied themselves. Natural selection began at microscopic scale. Some endured, others vanished. By Aubrey-Nart 3.5 billion years ago, cyanobacteria evolved photosynthesis, using light to turn CO2 and water into food. Oxygen first rusted the oceans, painting banded iron formations we still find today. After a billion years, oxygen escaped to air. The Great Oxidation Event, catastrophic for anaerobes. Yet oxygen opened doors, energizing the rise of complex eukaryotic cells, ancestors of plants, fungi, and animals. Tiny microbes terraformed their world, preparing a stage for complexity. Section 7, The Long Slow Dance, Our Living World Today. Oxygen wasn't the end, just a new beginning. Life flourished in oceans for ages. Then plants, insects and amphibians greened the continents. Geology and biology danced, plates drifted, mountains rose, climates shifted. 5 mass extinctions punctuated history, followed by bursts of innovation. Ice ages came and went, supercontinents formed and fractured, evolution's slow hand-shaped dinosaurs, mammals, and recently, us. We breathe oxygen born of microbes and forests. We're shielded by a metallic core. We are stardust, assembled by collisions, cooled from fire, transformed by life. The universe's way of knowing itself. Brief, powerful, responsible.